Well, the good and bad news is that there's probably not anything shocking in these last few slides that are on here, but we should take a look at them because it's a good refresher, and it depends too on what you're teaching and how far into these quadrilateral properties you're going as to how many of them you actually need. So there's a set of summary sheets on page 714, 715 in the book that has all the properties of the quadrilaterals. Now, some of these you've already seen before. Some of them might be a little bit new. There's two columns here. The first column is mostly definitions. The second ones are properties. So a definition is something that's essential to create that object. So if it's a trapezoid, how do you define a trapezoid? Well, once you've defined a trapezoid as a quadrilateral with at least one pair of parallel sides, then from there, other properties follow. So if you have a pair of parallel sides over here, then it's true that consecutive angles between parallel sides are supplementary, because it turns out that between a set of parallel lines, whatever angle this is and whatever angle that is, the sum of those two angle measures are going to add up to 180. And the same thing is true for the other two. Now, for a regular trapezoid, they don't have to be the same, right? This could be A and that could be B. And A plus B could also add up to 180. Now, if that trapezoid happens to be an isosceles trapezoid, well, now we've got something else going on, because besides those sides being congruent and one set of sides being parallel to each other, it's also true then that the base angles are congruent. So if the base angles are congruent, then the base angles are congruent here, and the base angles up at the top are congruent also, because they have to add up to 180. And the other thing that's true, and this will be true if you're teaching a high school geometry course, probably not in elementary or middle school, is that congruent diagonals mean that it's isosceles as well. So if that diagonal going that way is congruent to the diagonal going the other way, you've created a set of congruent diagonals, therefore it's isosceles. All right, parallelogram, basic definition, both pair of opposite sides are parallel. That's what makes it a parallelogram. So a set of parallel sides over here, and a set of parallel sides over here, right? That's the very basic thing that you need to create a parallelogram. Now, what else is true? Well, along the hierarchy, everything follows from the steps above it. So everything that's true for a trapezoid is also true for a parallelogram, except that besides just the consecutive angles being supplementary, now opposite angles and opposite sides are also going to be congruent. So DC and AB are not just parallel to each other, they're congruent to each other. Angle B up here is actually congruent to angle C down here. This angle up at the top here and this angle over here are congruent to each other. Opposite sides are congruent to each other. Some more, it's true, the diagonals bisect each other. And if you have a quadrilateral where the diagonals bisect each other, then it's a parallelogram. For the test, you're not going to have to go that far in depth, but it is true. And depending on what you're teaching, you want some extensions beyond what's the basic stuff in the book. There's some stuff that goes beyond the basics. Rectangle, parallelogram with a right angle. So everything that's true about a parallelogram applies to a rectangle. So for a parallelogram, we said both sets of opposite sides were parallel. That's the definition. So if you've got both sets of opposite sides parallel and one right angle, then you've got yourself a rectangle. Because if that's a right angle, 90 from 180 is 90, that's a right angle. Opposite angles are congruent, so that's a right angle. Opposite to B, that's a right angle also. So now you've got yourself 4 right angles. Right? Other properties of a rectangle, all the angles are right angles. And the diagonals are actually congruent and they bisect each other. I think on this one, the congruent is a little bit easier to see because you've got one triangle up at the top like this that's got a right angle in it. And then you've got another triangle on the bottom like that, where this has 2 marks, that's got 1, you got a right angle. These 2 triangles are congruent by side angle side, which means that these hypotenuse of each of the triangles, which are the diagonals, are congruent. And then it works the other way too. Flip it around, you got the other 2. All right, here's some stuff about kites. 2 adjacent sides congruent, then you've got yourself a kite. So a kite is one of these that has more than one option, right? We can have a convex kite, we can have a non-convex kite. So the convex kite is the one up on the top left corner here. You've got 2 pair of consecutive sides congruent. Down here, you also have 2 pair of consecutive sides congruent. So you can have a non-convex kite. What's true about a kite? A kite has a symmetry diagonal. So you draw that diagonal right down the middle of the kite. You reflect the top half, you'll get the bottom half. Works the same way for this one too. Draw that symmetry diagonal through the middle of your kite, reflect the top half, you'll get the bottom half. So that must mean that this symmetry diagonal bisects the angles down here, bisects the angles up here. When it does that, it creates two congruent triangles, which means that this angle here is congruent to the angle that's down here because they're reflections of each other. This textbook tends to teach the properties based on constructions. Other textbooks I've used have taught them based more on reflections and rotations, and you can see based on the reflections that those two angles at D and B are congruent to each other. If you were to draw in the other diagonal, right, the other diagonal is the one that extends this way, what's going to happen is that those two diagonals are going to be perpendicular to each other, and you're going to end up creating sets of congruent triangles when you do that, right? So you'll have a right angle here, and actually you'll have all four of them will be right angles. Right, one diagonal bisects the non-consecutive angles. We talked about that, and if that's true, then you've got yourself a kite. A rhombus. A rhombus is like a kite with extra properties, if you want to think about it that way. You've got one diagonal that goes this way, right? The top half and the bottom half are the same. You got another diagonal that comes down this way, and both of those diagonals are symmetry diagonals. In the previous one, only the diagonal from A to C was a symmetry diagonal. The one from D to B was not a symmetry diagonal. You flip this side over here, and you do not get the other side. So if you flip the side ABD, you don't get DCB. On the other hand, in a rhombus, you do. Flip top and bottom, flip left and right, you get the same thing. So not only are opposite angles congruent, opposite sides are congruent, but the diagonals bisect both of the angles. Okay? If that's true, then you got yourself a rhombus. So what haven't we done yet? We haven't done a square. If you take a rectangle and a rhombus and combine them, you get a square. So a square is basically all the properties. It's got the opposite sides congruent. It's got the consecutive sides congruent. It's got the opposite sides parallel. It's got one right angle. It's got four right angles. It's got diagonals that are perpendicular to each other. It's got diagonals that bisect each other. Every property that you can think of that is true for a rectangle and a rhombus is true for a square, right? So you can draw in those diagonals, and those diagonals have all the properties there. They're perpendicular to each other. They bisect each other, and they're congruent to each other. So that piece there and that piece there, that piece there, that piece there, all four of them are congruent to each other. So you actually end up creating four isosceles right triangles when you divide up those diagonals inside of that square. And that's it, the properties of quadrilaterals. So as you study this, I know there's a million things that were just kind of thrown at you. Focus mostly on the stuff that's in the first column. Those are the more important things that define what these figures are. The ones in the second column, I would worry about sides, maybe angles. I wouldn't worry so much about the properties of diagonals. And as you're studying this, if you got questions, make sure you ask.